Hi everyone, this is Richard. I'm going to present about the Boston Codeathon. So the objective is to predict the housing prices in these different areas of the metropolitan area of Boston. And so the first four steps, you got to I got the data from Kaggle. It was poorly formatted. So it looked like all the data was compressed together in a string. There was no data labels. So I went ahead and added those. And as you can see, there are 14 explanatory variables on the bottom left. You can see what they stand for. And there are 505 instances, and all the data are numerical data, which makes our lives easier. Now, moving forward with the histogram of these different variables, the first thing I noticed was the response variable MEDV, which stands for median um, price of the homes. So that's normally distributed. And then I also highlighted that these three variables, LSTAT, RM, and DIS, were also normally distributed. So I thought those would potentially be most helpful in any machine learning algorithm moving forward. Also, with the correlation matrix, as you can see, the three best correlated variables are LSTAT, RM, and PT ratio, which stand for respectively the percent lower status of population, the number of rooms per dwelling, and the pupil to teacher ratio. As you can see, the LSAT ratio that's negatively correlated, RM is positively correlated, and PT ratio is negatively correlated. But these would be probably the most important variables moving forward. So selecting and training a model. So there are three types of models I've tried, linear regression, decision tree, and random forest. And random forest yielded the lowest RMSE, so I selected that as the model to use moving forward. And all of this was tested using fivefold cross-validation in the training set. So for fine-tuning the random forest model, there was grid search and randomized search. With the grid search result, as you can see the different combinations I tried here, the best RMSE yielded was 3.3077. But with randomized search, I was able to get an even better RMSE of 3.29986. So moving forward, I decided to use the hyperparameters from the randomized search best result because of the lowest RMSE. And just another deep dive, look at the most important estimators. It was LSTAT and RM. And this kind of makes sense according to our previous correlation matrix analysis. So these are the two best estimators, and the explanatory power really drops off after this Rn variable here. So with the test set results, we were able to get an RMSE of 3.36993, which is in thousands of dollars. So you can think that it's about $3,370 on average that we're off. So here's the mean absolute error is 2.402 or $2,402 of error on average, which isn't really bad considering the total range of the housing prices. And as you can see on this right-hand side, the error we were able to decrease the error by selecting better and better models and through better fine tuning. But for the final test, the error did jump a little bit, did increase a little bit to 3.37. And that was just because, as that was just because of unforeseen data patterns in the test set. But the good news is that the error wasn't significantly higher, which would have indicated that there was overfitting. So there was no overfitting here, or very little overfitting. So we can be relatively confident that our model was adequate for explaining this. And then step seven, just presenting the model. So I decided to graph the two, best explanatory variables, which were LSTAT and RM. And as you can see, the blue is the actual data, and the orange is the prediction data. And the prediction data I think it closely follows the actual data. So the algorithm did a good job of sort of learning from these different variables and identifying the correlation. So the next step, I guess, just conclusions. So the error rate steadily decreased as we selected better models and fine-tuned them, but we didn't overfit the model. So the best predictor of housing prices in Boston, LSTAT and RM. So prices fall as as percentage lower status of population increases, rise as rooms per dwelling increases. And those are relatively intuitive results. But yeah, that is the end of the presentation. Thanks for listening.